Right, what is up, everyone? I'm coming at you with a video about the physics of landing and why are some landings harder than others? Why are some landings safe and some landings aren't? Okay, and it all has to do with this equation. I'm going to show you two examples with numbers why some landings are softer and safer than others. Okay, so the equation you see down there says that force multiplied by change in time equals mass times change in velocity. So this applies to any time that something collides with another thing and brings it to a stop, right? And it can be used in some other situations, but it's definitely can be applied to where something is brought to a stop by a sudden force. So here is Sergeant Drop. He has a mass of 50 kilograms. He has a nightmare, right? So this is not real, y'all. Don't worry. That he drops off a 80-meter roof onto a large rock. He would be falling at 40 meters per second just before hitting the rock. How much force would he feel from the rock? Okay, well, let's see. Right. So we need a little bit more information. Okay, someone would have to take a little slow motion video, a really slow motion video to see how long it takes from the time he touches the rock to the time he comes to a complete stop. Right, and let's say that is a very sudden 0.001 seconds. Now we can put numbers in that equation and figure out how much force he would feel. Okay, so on the left side, you have his mass and you have his change in velocity. Now we'll say that he was falling at minus 40 meters per second because he was going downward. Then he came to a stop, so his change in velocity would be positive, going from negative 40 to 0. Okay, so mass times his change in velocity would be the 50 times the 40. On the right side of the equation, you have force multiplied by delta t, right? And that delta t that you see is the time of collision, the time from when he first touches a rock to when he has stopped moving. And we're going to see as we do the math that delta t becomes very important because what we're going to do in order to solve for f, we're going to divide the left side by this number we see over here on the right side. So we can cancel out this number from the right side. Okay, so remember if you divide a number by a really small number, what do you get? You get a really big number. So if he really fell off this building and hit the rock and his time of collision was this small, 0.001 millisecond, then he would experience a very large force of 200,000 newtons. So he wakes up and realizes that jumping on the rock is a bad idea. So instead, he jumps off a building onto a giant pillow. Okay, he's still 50 kilograms, and the building is still 80 meters tall. So he's going to relive his nightmare, except he's going to have a pillow on the bottom to catch him when he falls. Now, the pillow, because it's soft, the time of collision is going to be longer. From the time where he first touches the pillow to the time that he brings him to a stop is going to be a longer period of time because the pillow, of course, is going to kind of be smushed, and that takes time. And let's say it takes him 2 seconds from the time he hits the pillow till he comes to a complete stop. Now, let's see how much that would change the force. Okay, so using the same equation, the left side looks exactly the same mass, same change in velocity. But on the right side, you have force multiplied by delta t, and the delta t is 2. So just like before, we're going to divide. This time we're going to end up with a much smaller number of 1,000 newtons, which is a force that, most people have no problem surviving, right? In fact, for a lot of us, that's how much force we feel on our feet every day, right? So he has a soft landing, one with small force, and the reason is a long collision time. So things that stretch out the time that it takes you to come to a stop are safer things to run into or land on than things that are bring you to a stop suddenly. Okay, so that's why we have airbags. That's why when people jump off of tall things, they usually jump onto some type of blanket or trampoline. That's why if you play sports, oftentimes you have padding of some type, right? All those things are trying to stretch out the time of collision, which results in a much smaller force. So that's the physics of landing. That's why it works. I'll see you on the next video.